Hello. Welcome to this video lesson in which we will learn how to design a neural network using TensorFlow learning system and Python programming language. The neural network that we are going to design will be responsible for predicting the price of a rental apartment based on some input parameters. Furthermore, once trained, the model will be exported to be used in a web application, this time programming with JavaScript. Let's get started. In order to design a neural network, we must have data. In this case, what it has done has been to compile a series of parameter information from a real estate website. A few data have been chosen, but you could choose more. A total of 15 samples have been chosen to train the network. In this case, 8 input parameters have been defined: the city, the square meters of the apartment, the number of rooms, the floor level, whether it is an elevator, whether or not it is exterior, whether the apartment is renovated or new, and if it is located in downtown. For this example, these data are enough to be able to work. If you look at the array, what has been done has been to create sets with those parameters. Each set is a different floor and the data has been normalized. That is, in the city it is a number that in this case is 0. Square meters is obviously a number as is, the same as the number of rooms and floor level, but in the case of elevator, exterior. State, or if it is located in downtown, has been normalized with some numbers that are what we are seeing there in the comment. Apart from the array with the characteristics of the samples, we have a network with the prices for each one. The price that is in position 0 of that array is the one that corresponds to the first set, to the first floor, so through this data we will be able to design a neural network. Before starting to program the neural network, let's define its design. In this case, we are going to define an input layer, which will be responsible for receiving each of the parameters. Therefore, we will have 8 neurons in that input layer. A hidden layer for processing the data information that will also have or will have 8 neurons, and an output layer with a neuron that is going to predict the result, which is going to give us the price. In what would be the hidden layer, we could indicate more neurons. Here we can do all the tests we want. Now we will see it in the programming. We could even define more than one hidden layer for information processing. But we are going to start from this design initially. We are going to have 3 layers with a hidden layer. They are going to be dense because we see that the output of each neuron is connected to the input of each of the following ones. Well, as has been mentioned, here there is no predefined design of what can be done, but rather you can experiment with the number of neurons in the hidden layer, with different layers, etc. Now, we open a code editor, in this case Visual Studio Code, VS Code. I have created a folder called rental_apartments with a file called redneuronal.py. We are going to import the libraries that are needed, in this case TensorFlow. We install it using pip install TensorFlow. And we now have all the input and output data that we were seeing. First of all, we are going to define the layers. In this case, we are going to establish an input layer. That input layer is going to have 8 neurons. Therefore, in units, we are going to define 8 units. And we are also going to define that we will have 8 inputs that are the different input data for that layer. Here what we use is the Keras framework that makes it easier for us to implement the different layers of the dense type. Next we define the hidden layer. In this case, there are another 8 units that we have initially designed like this, and then finally the output layer that we will establish a single unit. Once the 3 layers that make up the neural network have been defined, the next step will be to use a sequential keras model, in which we will indicate the layers that we have created. Therefore, from the keras framework, we are going to use the sequential function, and we are going to indicate the order of the layers, obviously the input layer, the hidden layer, and finally the output layer. In this way, we are already telling the model the different layers that we will use in the network. The next step is to compile the model to prepare its learning process, and we are going to indicate within it the optimizer. In the optimizer, we are going to use the atom function. This function is responsible for receiving the learning rate. That learning rate, what it is going to do is efficiently adjust the different weights and bias so that the learning is as much correct as possible. And finally, we need in this compiler the loss function, in which we will use the mean square error to obtain an optimal result. What this does is that it measures the average of the errors. That is, what it does is that it establishes the difference between the estimator and what is estimated. The next thing we will do is train our network. Therefore, we are going to print in the console that our training starts. So we have it indicated when we execute the script, and in the history variable, what we are going to do is store all the training result. Note that we are going to use the fit function to which we are going to pass the inputs, we pass the outputs, and here, important, we are going to indicate how many times we are going to train the network to generate the model. We are going to do 1,000 iterations, and finally we are going to use the verbose parameter to false so that nothing is printed in the console, otherwise the entire process will be printed. And finally, when the training ends, it will tell us. Next, what we are going to do is import a library widely used in Python to graphically represent information, which is matplotlib. If you do not have it installed, you have to install it with pip install and the name of the matplotlib library, and next, what we will do is graph the history of error reduction. That is, we will be able to graph. We will see correctly how the magnitude of loss has been decreasing as the error has been reducing during the training of the network. Then we define the labels for the x-axis and for the y-axis. In this case, epoch will be the number of iterations, and in y we indicate the level of loss magnitude, and next to the history, once our model is trained, we are going to collect the information of the loss parameter to be able to graph it correctly. And finally, we are going to show, I think it would be our graph. The next thing we will do is implement a function on the network to save the model. Therefore, we are going to open the terminal and we are going to create a folder to be able to then export it in there. Then with the mkdir command, we are going to generate a folder that will be called app_pisos. And we already have it created, and then we are going to call the save function to be able to export the model. What it will do is export what that model would be in the H5 format. Very good. Then we see that we have the data, how we have generated the different layers that we need, then the model indicating the layers and how we compile it with. What that learning rate and the atom function would be, and finally we are going to graph the training of our network and then saving the model in H5 format. There it is starting the training. And there we see that it has already been executed, and there we have model.json and the file binary. perfect because those files are the ones we need to be able to later implement our trained network model in a web application, which is the next thing we are going to do. We are going to start designing our web application, and to do this we go to our project folder app_PSOs, and we are going to create a new file. This file is going to be in HTML. We call it index.html, which is the one that will also contain the JavaScript. To facilitate the design part, we are going to use Bootstrap. Then we go to the bootstrap.com website, and we are going to copy the link to be able to have the CSS functionality. We are going to create what would be the basic structure of an HTML file, and we are going to paste the link that we have copied on the page perfect. Now here what we are going to do is create a form. We are going to create a form for entering the different data. Then we are going to generate a container. This container will have a div with what would be a row and also another div, which we will establish the column with a series of provisions so that it is seen correctly. Here we are going to create a kind of card where we will indicate the title of what would be our form. We are going to place another div that will be the card we were talking about. We give it an upper margin, a little shadow, and inside what would be the body of the card. Almost all of these are the Bootstrap classes that make it easier for us to have the design easily. Now in here we are going to establish the title, for example, with an H4, and we are going to establish that it is centered, and what we can put, for example, is Red Mural Apartments for Rent Valencia. Now next we are going to create another card which will already contain our form. Therefore we write a div with the card class. We give an upper margin that fits more or less, and we would also establish a little shadow so that a little more than that card, and here inside the body of the card, which is the one that will contain the different inputs. For example, we are going to write a label to identify what would be the first input field, which in this case will be the square meters field, because the city, as it will be in this case, is the same. We are not going to include it. We can define it directly in the prediction, and we are going to write an input with the form control class so that it gives it the correct appearance, and we can also define that lower margin, and we will establish that number is going to be a numeric, that input, and we establish an ID for it later with JavaScript to be able to access the data that we have written and be able to give it to our model. We can copy this and paste it. Next, the next parameter would be the number of rooms. It will also be an input that will be numerical. We obviously change the ID to identify it correctly, and to next, if I remember correctly, we are going to establish the level floor, which will also be numerical, and we will change the ID. The following fields will no longer follow inputs. They will be selects because we are going to be able to select. In our case, we are going to select if it has a new elevator, and we are going to put the option in the select. First, we write the select. We will establish the form control class the same so that it has the same appearance, and we put a lower margin in it like the other fields. We are also going to identify it, and we will put the elevator ID. Very good, then select. We put the different options that in this case will be 0 or 1. 0 in case it does not have 1. We are going to change it as a value instead of text. We will put the number, although later in JavaScript to make sure we will convert it to in everything we have from the input fields, value 1 for yes. And we are going to do the same with the rest. We can copy it and paste the continuation because the rest are going to be selection fields. We are also going to take the label. We can separate it a little so that it looks better. Very well, we change the ID. In this case, the ID will be exterior. We take the label as I mentioned and we will put it below. And in the case of exterior, it has two options from 0 to 1, yes or no. We copy this and paste it below, and we will indicate the state that is in our case it does have more than one option. Because we will have the value 0 for no rehabilitated, we set the value 1 for rehabilitated and the value 2 for in the case that it is a new apartment, we apply new. We copy the same for the next one and paste the next one. We will indicate if it is downtown or not. We change the ID, and in this case it would be 0 or 1, the same. Now we only have to add a button and the text where the result will appear to our form. We are going to put the class deflex so that we have the button and the result in the same line horizontally. We establish the btn class btn primary. We are going to put the text calculate price. And we are going to define the type of button that will be, since we are going to establish the actions with JavaScript, and we establish an ID that can be btn, for example. Next, we are going to establish a text label, an h5 itself, with the result ID, which is where that result will be shown in the prediction of our model, and we establish the class. In this case, we are going to put a horizontal margin of 5 so that it is separated from the button and a top margin of 2 so that it is in line with the button. Very well, in this way we would have the design of our form, that part of the HTML. Let's see how it turned out. We go to the project folder and execute the index.html, and there we see how we have the title and our form very well. There we have the inputs. If we look there, we see that initially the first option appears in the select thing. We are going to put a first option that in this case will be disabled and selected that tells us to choose in the option. We put disabled selected so it will be better for us, and we put, for example, choose an option. We are going to put that in all the selects, so by default that will initially appear in those fields. We're going to save it and look at it again. We're going to update it, and now it looks much better. Perfect. Very good. Now we have it. Let's start writing our JavaScript. In our index.html file, we are at tensorflow.org because through this web page we will be able to access the script that will make it easier for us to use that functionality in JavaScript. Therefore, we return to what would be our code editor, and we are going to write our script tag. Very good. This is where we are going to write our code, but first, as I mentioned, we are going to go to the Learn menu. We are going to go to JavaScript, and we are going to see the Tutorials option, where if we go to Setup, we are going to have that script, and we have it. We are going to copy it to be able to have the TensorFlow functionality in our code. Before what that script tag would be, we are going to paste it, so we will be able to access it later and we will start writing our code. We are going to define a variable that will be a model that we initially set as null_and. Next, we are going to create what would be the loading of the model that we have trained and that we have exported before with Python. Here we are going to use an asynchronous function to access it. So we use the arrow syntax, and within this function, the first thing we will do is print in the console if the loading of the model has worked correctly. Therefore, first we indicate loading the model before to do the action, and then we are going to use the word await to use that model variable. since we are inside an asynchronous function, we are going to load the layers of the model. Very well, here we have to tell you the name of the JSON file that will be called model.json. The next thing we are going to write is in console if everything has worked well because the model is loaded. Very good. Then we would have that asynchronous function that we use to load the exported model of our neural network. Next, what we are going to do is access the button, since we need that when we press the button, it collects the data that is in the input fields. Both we access it, and we are going to define the event with click. We are going to put btn.onClick. Well, we put the arrow syntax here, and the first thing we will do when pressing is collect the different data to be able to predict the result. Therefore, we are going to access all of them. Square meters in this case, we need the ID, and we use value to collect the input. Very good. Now the next one, which is rooms, we do the same. We collect information through the ID. Then the floor level, the same as we collect its value through the ID. Let's see elevator. We collect if whether it is exterior or not. The same good. I have put ext because I change it right here. And we are missing the state, and if it is downtown or not, then we go to the state, and finally downtown. Very well. Once we take the values, we are going to establish a condition, so that if the model is different from null, that is, if the model has been loaded, we can make that prediction. Therefore, we are going to declare a variable that we can call a tensor. And through TF, what we will do is use a two-dimensional tensor because the input data is in 2 dimensions. They are sets that in each position of the array that we have defined in Python. At each position, there is a set with the 8 data. That's why it has to be 2-dimensional. It's a matrix, and we're going to pass the different data to it. The first parameter is 0. Which is going to be the same for everyone because we haven't defined that in the form, and then we're going to indicate the square methods. Say all data that is also numeric, we are going to convert it to integers so that we do not have any problem when collecting it from the input. If we make sure that they are going to be numbers, then we are going to pass them all in the order in which we have defined the entries in the array from Python. Very good. Let's see that here we have a perfect exterior condition. A parenthesis has slipped in there. I'll remove it. And finally, it was still central. Important, if we indicated 1 dimension, it would not work since it is a matrix. It has to be 2 dimensions. And then we are going to obtain the prediction, which we are going to store in that variable through the point predict model, and we pass it the input data that is stored in a tensor. Very good. Now what we can do is predict. We are going to define because if not, the result does not give us enough decimals. Since that prediction is already the price, we are going to use the round function of mat, and we are going to limit it to 2 decimal places. We are going to access sh5, which already has the result to be able to show it. Therefore, with inner HTML, we are going to show it, and here we can put the price 2 points a space, and we are going to concatenate with prediction. That contains result, and we can then concatenate a text with euros month, for example. Well, there we would already have in the case of receiving the prediction. We can put an else, so that if the model has not been loaded, we cannot display anything. Then we can put a message in that same H5. We can put try again, whatever we want. Perfect, because we would already have our JavaScript code. Notice that it has been quite simple, in which what we do is access the model that we had exported. Very well, the next thing we are going to do is open the terminal in the Flats app to run our application through a port of a local server. Therefore, we can use Python, a script and simple HTTP server. And we indicate the port number. For example, 4000. We press enter. We are going to execute it to see if it works correctly, and there we see that it is telling us that. It is running on our local server port 4000. Let's go to the browser and we will access localhost 4000. Very good, and there we see that it has been executed correctly. We are going to see the console if we have an error or something, because there it says loading the loaded model works correctly, and we are going to enter data. We are going to test it. Let's say, for example, 110 square meters, 3 bedrooms, 4th floor, has an elevator, is exterior, is in a renovated state, and is centrally located, and is giving us a price of 1,336 euros per month. Very well, we see that it works. If we change it to non-central, we see how it drops to 931. Perfect. It has dropped 400 euros. For example, let's tell you again, but let's go. To take away that it does not have an elevator, therefore it drops us to 1,258. If, for example, instead of 110 we go down 80 meters, it also lowers us a little, and if we say that it is not central, we see that it drops quite a bit, 750, with the parameters of input. Therefore, well, we see that it works correctly. Depending on the data with which we have trained our neural network, the ideal here would be to add more data so that the calculation is much more precise in the prediction. But we see that with those 15 data, it has worked quite well for us. Well, I hope you liked this activity. It is quite interesting, and it has not been very complicated to design our neural network. But as I mentioned, well, I hope you liked it and that it is useful for your projects, and you can start exploring and creating your own neural networks. Take care and see you in the next video.